Today we will discuss about Reimer-Tiemann reaction. You all have heard about the Reimer-Tiemann reaction, which is basically a formylating reaction or formylation reaction of aromatic phenol derivatives. Since this OH group is ortho as well as para-directing, group, hence two isomers will be obtained. One is the ortho formylated product and another will be the para-formylated product. Okay, so what is the reagent for this reaction? The reagents are basically, you all know about this, sodium hydroxide in chloroform medium. So if we treat any phenol derivative with sodium hydroxide in chloroform as a solvent in heating condition, we will obtain the formylated product. Okay, so what is the mechanism of this reaction? Initially, the sodium hydroxide reacts with chloroform to generate the dichlorocarbene intermediate, which is actually the electrophile which attacks the aromatic system. Type of carbene is this? Is it a singlet carbene or triplet carbene? Obviously we all know that triplet carbene don't act like a electrophile, it acts like a radical, and any reaction which involves the reaction between a reagent with triplet carbene proceeds via a radical reaction. So this is not a triplet carbene, so obviously this is a singlet carbene. And what is the hybridization state, or rather the bonding of this carbene derivative? The central carbon is sp2 hybridized with a lone pair in the sp2 hybrid orbital, and the other two sp2 hybrid orbital are making the bond with two chlorine atoms, and it has a vacant p orbital, which is obviously the reason for its electrophilic behavior. Okay, so now let's look at the mechanism of this reaction. So first, the OH group will assist the nucleophilic attack of the aromatic system towards the dichlorocarbon intermediate, which will generate this intermediate. And since the aromaticity is lost, in this step, in the next step, re-aromatization will take place. The negative charge will abstract this hydrogen and this intermediate will formed. In the next step, water molecule which is present in the reaction medium will attack this carbon center following a SN2 mechanism, which will result in the leaving of a chloride anion. This intermediate then form, the OH bond will cleave and the Cl- will leave from this system. And this product will be obtained, which is salicylaldehyde. Salicylaldehyde. So this is a mechanism for the ortho formulation. So you guys can do the para formulation by following this mechanism, exactly same mechanism. Okay, you can also perform this reaction on heterocycles such as pyrrole. The initial reaction between pyrrole and dichlorocarbene will generate this intermediate. And then re-aromatization step. And then the hydrolysis step. And this is our final product, formulated pyrrole derivative. In addition to this product, another product is obtained during the formulation of pyrrole derivatives, which is this compound, that is 3-chloropyridine derivative. So how does this compound actually formed during the Reimer-Tiemann reaction. So we all know that the aromaticity of benzene ring is much more higher than that of pyrrole derivative, or in other words we can say that the double bonds of pyrrole compounds are like a localized double bond type. These two double bonds have some localized double bond character, and which leads to the cyclopropanation reaction with the dichlorocarbene intermediate. To generate the cyclopropan derivative. So what is the cyclopropanation mechanism? This lone pair attacks this carbon center and the double bond attacks the dichlorocarbene carbon center to generate this cyclopropan derivative, which then undergoes a intramolecular rearrangement and a chloride ion leaves from the system to generate this protonated 3-chloropyridine, which eventually loses a proton to generate this ultimate product. So now it's clear that how the 3-chloropyridine compound is generated during the Reimer-Tiemann reaction of pyrrole. Another example, if we carry out Reimer-Tiemann reaction on this compound, then two products are obtained. One is the orthoformylated phenol derivative, and another compound is this one. So the first, that is the orthoformylated phenol derivative. The formation of this, you all can explain this by following the normal mechanism of Reimer-Tiemann reaction. But what is the reason for the formation of this compound? You can see that after the attack of the dichlorocarbene species, the reaction essentially stops there. Nothing happens further, no hydrolysis and no rearomatization. Excuse me. So what is the reason for this abnormal Reimer-Tiemann reaction? So after the reaction between the phenol derivative with dichlorocarbene, this intermediate forms, which then abstracts a proton from the solvent or minute amount of H2O present in the system. To generate this compound, you can see that here is the methyl group and no hydrogen atom, so rearomatization cannot take place since CH3 plus cannot leave as proton to rearomatize the system, because CH3 plus is much more unstable and cannot leave as CH3 plus. Okay, so one reason is this, and another reason is that if you look carefully, this carbon atom, it is attached with a neopentyl type moiety. Neopentyl moiety, you all know what it is. This is a neopentyl system in which a CH2 group is attached with a carbon which is bound with 3 methyl groups, which is sterically very much hindered, and no SN2 type reaction takes place in this CH2. That's why no further reaction takes place and water molecule cannot attack this carbon atom to transform this CH-Cl2 group into a CHO group. Okay, so there are two reasons for this abnormal product. Number one is methyl group in place of hydrogen in para position, and number two factor is neopentyl type environment prevents the conversion from CHCl2 to CHO. Okay, so these two are the main factors. So that's it. This is the basic mechanistic concepts of Reimer-Tiemann reaction. If you want to know further about this reaction, or if you have any doubt, then you can leave message in the comment section. Thank you for watching this.